Everyone, November the 5th. Alright, what I can tell you guys is Oncall is, or at least maybe I'm not doing it right because I'm tired just from those Oncall stuff. I mean, so many tickets. Lord. Alright, anyway, let's do this. Find if array can be sorted. You're given. Hold on, I need my water. Alright, let's do this. Zero indexed array. In one operation, you can swap any two adjacent elements if they have the same number of set bits. Set bits. Set bits. What? You're allowed to do this operation any number of times. Return true if you can sort the array, return false if otherwise. Hold on. You can swap any two adjacent elements if they have the same number of set bits. Holy crap. Okay. A42, they have one set bit. 30F15 have four set bits. So we can sort the array using for operations. So I mean, the bubble sort is, wait, is it bubble sort? Yeah, bubble sort is swapping adjacent, right? That's bubble sort. So if you have adjacent ones, I mean, basically you can partition the original array into groups of numbers that can swap within themselves, and if they are free to swap, that means it can be, hold on, my cat is doing something bad. Yeah, so if it can swap, that means we can sort, right? That means we can sort. So basically, all we need to ensure is within each group, like the groups have already been sorted. That's basically what we want to do. Yeah. So basically, in this case, 8, 4, 2, 30, 15, right? So this is a group, min is 2, max is 8. This is a group, min is 15, max is 30. So all we need to do is ensure the max of this group is smaller than the min of this group, and then this one can be sorted. So we need to know the number of set bits, right? So when you call a function, does Java has a function to do that? Get number of set bits in integer. Bit count, integer.bit count. Okay, so I have integer.bit count. So for each one, I get a bit count, right? And then I also get its max, right? I got its max, its min max, right? It's min max, and I save it somewhere, and then I move on to the next group. I got a min max, and then we compare this min max with the previous min max. If the two are already sorted, then we're good. If the two are not sorted, then we're bad. Because within the group, you can sort, you can swap, right? Okay. Yeah, let's give this a shot. I have this idea. Let's see if this idea works. So min max, so int min is 0, int max is 0. Okay. And then actually no. Int min shall be nums 0. Nums 0. Right? And then for int I equal to 1, I smaller than nums.length I plus plus. What we need to know is if they're the same, right? So if integer.bitCount nums I is equal to integer.bitCount nums I minus 1, right? If this is the case, then we say min shall equal to math.min min and nums I. Max equal to math.max max nums I. Right? So we just update. If they're not the same, okay? If they're not the same, then we have a new group. And we have a new group. Oh, we need 2 sets, right? We need 2 sets. We need a previous and we need a current. Oh, okay. So we need to have previous min, previous max. Okay. So this is the current, right? And if they're not the same, right, if they're not the same, so we hit nums I, which is not the same as the previous. Because we can only make the comparison after we finish the entire group. And then we compare to the previous, right? So now what we're gonna say is if min is large, let's say sorted, so large or equal to previous max, okay, then we're good, right? Then we're good, and we will do some swaps. So maybe we can do an else if, you know. Right, so if min is larger than equal to the previous max, then we say previous min will equal to min, previous max will equal to max, and then min will equal to nums I, max will equal to nums I. So we just have a new one, right? Else, if min is smaller, and in this case we simply return false. And then if we finish do this, we'll return true. Something like that. Alright. Oh, that is not right. How come it's not right? Bit count. What's the bit count? 3 is bit count 16. These two has different bit count. So that's good. Right, it's bit count. And then all of this is bit count. And I have a min. Right, min is 2. Larger than previous max? No. So it should return false. Alright. Let's take a look. When it gets out, because the last one after I finish, right, it's basically this. So when I get out, we shall say min larger equal to premax. That should be good. There you go. It's 3011, right? So what we can say is within a subarray, right, of numbers of the same bit count, they can always be sorted because there is no restriction on swapping between subarrays of different bit count. There is no way to swap across, right? This across the different subarrays. Hence, for these subarrays to be sorted, the max of the previous subarray must not be bigger than the mean of the previous current subarray. Oh, I never used previous min, which is true, so I don't even need to use that, right? I do need min, I do need max, but I don't need a previous min. Okay, we'll run this one more time, submit it. And call it a day, because I'm hungry and I need to eat. I'm pretty sure that is a solution. Bubble sort. Sortable segments. Forward and backward pass. Yep, this is my way. What's this? Forward and backward pass. Move the maximum value of each segment as far to the right as possible. And then in the second pass, we switch directions, iterate from right to left. This time I focus on moving the minimum. When making these passes, if we come across a pair of elements that should be swapped but can't be because they have different numbers of set bit, we immediately return false. This means that sorting the array under the given constraint. So we do left to right. If this we continue, otherwise we count. Okay, so if we count and they can be swapped, then you swap them. If they cannot be swapped, then it's bad. Second pass, the same thing. So basically we just say the smallest will go to the front of the group and the biggest will go to the end of the group, and if they can, that means everybody inside can be sorted. Yeah, it will work. Okay, that will be it. Yeah, I'll just call it a day today. I'll see you guys tomorrow. Adios.